Hello and welcome to another Out of Spec podcast episode. You join me for now, but actually we'll be joined by my friends Emad, Dlala and Peter Rawlinson from Lucid. Peter's going to just kind of dive into this interview in the middle. It's really funny. He's a great dude. And we are talking all about charging with the Lucid Gravity. This is their new electric SUV. And recently I've had the chance to actually drive it and make a first review video for you guys. And I think we really gave it a glowing review. I've spent thousands, tens of thousands of miles driving their first product, the Lucid Air, all across the country on multiple occasions, cannonballs and other things. And we really got to know that car. And most recently, Lucid loaned us a Lucid Air for a few months, and we put 15,000 miles on it and just dove into that entire car. And we really came away super impressed with the updates they had made from the early cars that we had tested to the most recent 2025 sort of mechanical refresh models. That seems to be just like such a small piece to the puzzle of their engineering excellence, because what you're about to hear about gravity charging is going to be absolutely insane. So in this episode, I'm going to walk you through some of the highlight specifications of the Lucid Gravity's charging performance, which has been the big question mark outside of all the reviewing stuff that we've done. This is the last component to know about. Then we will interview Emad Dlala, who's head of Powertrain and just an absolutely amazing engineer at Lucid and a friend of mine. Really love him. And Peter's going to step in for a minute, which will be funny. And then at the end, we'll share our final thoughts. I think it's going to be a fantastic video if you love electric cars and nerding out. So join me for a deep dive of the Lucid Gravity's charging performance.
This episode is made possible by the support we get from Fort Collins Kia. If you are in the market for any electric Kia, not only do they never add market adjustments, they will deliver your car to you anywhere in the 48 contiguous states for out-of-spec viewers. More information in the link in this episode's description.
Well, guys, you join me with my friend Emad here. We're talking about all things Lucid Gravity charging. For those of you who don't know, Emad and I have spoken for, I guess, years now, and we've gone back and forth on charging figures, charging times. How should we test the cars? Our 10% challenge was actually developed with Emad and his team in mind to showcase the amount of distance that we can get from charging the Lucid Air at the time in a 15-minute charge cycle. So welcome to the channel, I think for the first time, right?
I think first time in live in the podcast session. I'm not sure if we've spoken in the other channels. I can't remember.
Yeah, we must have done something at some point. But so, okay, the Lucid Gravity specs on first glance seem pretty impressive. I mean, we're talking 400 kilowatt peak. I got to talk to you all about the version 3 supercharging thing. But can you give us a general idea on like, where did you start? How did you decide this had to be different than the Air, and where did the targets come from?
Yeah, at Lucid, we usually say we don't set targets because targets can leave you in a very either inferior position or reaching something you cannot reach, and then it would make it like feel like a failure. So we always use our engineering prowess and our scientific approach to really understand the limits of the physics, the boundaries in terms of attributes, which includes, in this case, charging speeds, lifetime, energy range, efficiency, as well as cost. And you got to make those engineering decisions accordingly. And in this case, you refer to 400 kilowatt. 400 kilowatt is important milestone, but really doesn't it wasn't the main goal of the entire charging engineering development.
So it all starts from the cell. Before we get into the data, actually, a couple weeks ago, I guess it was, you guys issued like a communication with Panasonic sharing, okay, you're using their 2170 cell, super high energy density. It's like 800 watt hour per liter or something, which I think it was like Model 3 2170 was another 100 watt hours less than that. So it's really like a pretty serious cell. But there's so much that goes in beyond the cell, of course, and how it's integrated as a total system. And I love now that you are retaining the highest voltage vehicle on sale with the whole system up to 926 volts, because I don't know if I told you this yet, but I went and I drove a Neo this past week in China, and they got 925 volts. I was like, damn, they beat Lucid Air by one, and now you got them back with the Gravity.
Yeah, I mean, before even that announcement or mention of 925 volt from Neo, we had 926 for a while, real volt for Gravity. Really, you can't change voltage overnight, and those charging parameters actually have been tested for a quite long time. I think your question was about the battery cell and the chemistry and what role it plays. We started Lucid Air, of course, with a similar mindset and approach of using science, challenging the status quo, respect what the industry does, but don't follow it. However, it was our first product, as you know. It's we do have amazing overall specs of Lucid Air, but we learned so much. Lucid Air was our first product, and even when you assemble your best people, the best people, doing the first product will always be some learning. And in this case, of course, in terms of developing the chemistry, we really at Lucid, and I think we took you to a tour one day, Kyle, around here, and we do have much more capability since then in terms of both the modeling side and the testing and characterization side of the chemistry. So we have built our own models really to understand what's the limit of lithium plating, what's the impact of temperature, what's the impact of cycling at different, let's say, C rates and at different rest times. And with that capability, we have also at Lucid a group of people who work in the system. And I mean, the cell by itself, of course, is integrated into a pack or module, and then at the vehicle level. And you need to really design that system holistically. And I would say very few companies who could do that, that they have this engineering capability and vertical engineering capability all across these areas, and from hardware, software, BMS, of course, is a huge part of that, the system characterization, and the cell chemistry. And we worked very closely with Panasonic, and we actually iterated with them about the chemistry, about its, let's say, strengths and weaknesses back early 3 years ago. And we did end up with a chemistry that has, I would say, overall amazing, characteristics. And we do have, more to come with in the future as well, because, from here, we are working on a mid-size chemistry, which will be amazing too. And I think the Gravity is going to be a great basis for that.
So the one point that you brought up was cell characterization. And this was a really big topic when we were testing Air in the early days, 2022, 2023, where what you guys explained to me, you were kind enough to bring me into the labs, and we met with your battery team. And you said, "Hey, Peter, how's it going?"
What's going on here then?
Hey, hey,
Do you mind if I
what?
join you?
Yes,
Yeah, join
yeah.
us.
Hi,
We're
how you
talking
doing?
cell
Hello?
characterization.
That's,
Yes.
So essentially we went over there, and what we learned from your battery team was that your cell suppliers at the time didn't even totally understand the performance of the cell in a vehicle application completely. You were getting completely different data in your own testing. So now you can essentially take what Panasonic tells you, you can run the cell through your own characterization process to simulate how a vehicle's used in its own environment, and then tune the BMS and the car's behavior off of that. So Emad and Peter, maybe you can tell me a little bit more about that process for the Gravity?
Yeah, so I can take a stab at it first, and then Peter will chime in as well in terms of how our all approach of science and physics and how we take engineering from a clean sheet mindset. Yes, in terms of cell supply capability, they usually provide cell chemistry that really tested in a very and developed in a very I would say a way in a very basic way in terms of overall integration in a vehicle. So they do have some profiles that we share with them, but when it comes to understanding the limits of how many, for example, thermal cycles the cell can take, because it's only Lucid is able to understand the system's capability. Also, how we can also go over any edge cases that the cell cannot or may not handle in an ideal circumstances, how our BMS can be smart to really make the cell still safe, with long life, but take its boundary to a next level. So and this confidence and comes from having a team that's really talented and capable. I mean, what's special about this technology is its energy density fused with its power density. I think that's the magic here. And this could be understated. And it's very cost effective also, Cell. We want, of course, to build a business at Lucid here, not just a single car. And we look at those attributes, as I mentioned, energy cost, safety, and power in a very holistic, systematic way.
And I mean, take the point of the BMS. We're not looking at an individual cell characterized individually. We have a series count of up to 220. That's how we get the 924 volt. So it's 926 now.
Yes.
Note that. It's no longer 924. But we have certainly on all our modules, we have a 30 cell P count. So we have to balance the workload across that group of 30p, because you get lazy cells and you get energetic cells like human beings, and you want to even out the work with that 30p count all the way up that voltage staircase, the 220 S count. But are you talking about our new charging
We are going to get there.
Yeah. It's just
Yeah. So have you seen the data, Carl? Have you seen?
Oh yes, seen the data. Okay, I mean the big news is peak is one thing. I haven't seen the curve yet though.
Mm-hmm.
So the curve, I'm excited to learn more about. Peter, tell me about the curve. What's it like on a DC
You will
charger?
like the look of the curve, Carl. I like it, and I know when it's good. I've seen it, and we've discussed it. It's great. It's a good curve.
Okay, we like a good curve, and then we haven't even gotten to the boosting profile yet, but we're going to get there. We're going to talk about the benefits of having complete voltage control on voltage limited chargers.
Totally, and that is the big advantage over a split pack, because with the boost voltage, you can take full advantage of the available voltage at the charging station, and you are limited on maximizing your usage of available voltage with a split pack,
independent of SOC.
Yeah,
with split pack you have at low SOC it's a strange, like at low SOC you need the highest power because the cell can take the highest power. But the problem, your voltage is low. So that means your charger can come in.
That's right. You get the open circuit voltage just dropping
Yes.
SOC, and that's what calls you a split pack.
Yeah. So you remove that from as a variable, your SOC variable.
It's very, very subtle, Carl. And the interesting thing is we've had this patent. When did we register it? 2019?
2019 was basically published.
It
was filed before that.
So really the impetus has been us joining NACS now and having availability to that system, which we didn't perceive we would have that opportunity in 2019. I think it's been great for our customers, And it's just something that we really want to improve the whole experience for the customer, and to get in excess of 400 kilowatts. I think we're disclosing 400, but we may be a little one side of that. I live near the 405 in Los Angeles, so it's cool to be one side of the 405 car.
Well, okay, so we're going to need to find a charger to actually max this thing out. That's going to be the hard challenge, is can we find a piece of infrastructure that can get it up over 400 kilowatts? I think, in
Yeah.
general, 400 seems like a great number to communicate, especially because there's so many variables with charging. So if that's a number that a user could really hit in the real world at low SOC, I think that's a
So,
good
and,
indication.
I mean, I want to be transparent with you, Kyle, because I think, that the charging curve is going to be really amazing. I mean, in terms of energy added, let's say in 15 minutes, I think it's going to be top over there.
It's far less peaky.
Yes, and
because anyway, you can quote a peak. It's the integral of power across that range of SOC that matters.
yeah, and it's usable energy in 15 minutes. It's going to be overall the best. I mean, that's what we're in right now. Shooting for, and we will show you sometime soon these capabilities, hopefully tested, validated. And the 400 kilowatt, as I said, is we do have, and I want you to kind of ask you too. I mean, with the access to V3 with that 225 kilowatt, with the amazing charging curve, with the peak power, we deserve to have a peak power that takes it to the next level. I think the story, for peak power is still kind of important, but we didn't want to just do it artificially for peak power. We want to make sure that really the charging curve really supports that. And you know me, I had lots of conversations with you about it, and I respect your feedback. What we improve it to, Kyle, is really the insensitive, less sensitive impact on temperature. So preconditioning is important. Someone like expert like you will always hit the button or navigate, but not many people do it. And we really made huge improvement to allow for amazing charging capability at various temperatures. And this is the experience. This is what I'm telling you. The 400 kilowatt, yeah, it's a one milestone, but how you make the experience overall really excellent. And I think that's where we're focused on, not just the peak.
So huge. Forgive me, but I've got to go. But been called away. But a huge shout out to the engineering team under Emad's leadership, and a big shout out for software as well, because software it's really a fusion of hardware and software
100%.
to enable this. A huge software effort within the company. So
it's
well done.
It's one team. Powertrain, a battery BMS software, hardware, and of course also eventually to build a product, you have all other supporting functions to do it.
So
thanks, Peter.
Can't wait for you to experience it.
Thank you, Peter.
Yeah, thanks, Peter. Appreciate you joining. Okay, so Emad, before Peter rudely interrupted us, I'm just joking. Can we talk? So we were talking about the cell. Then I want to go.
Peter got too excited to talk to you, Kyle.
Yeah, then we got all geeky way too fast, which is great. I love it. That's why we do these things.
Yes.
So I want to talk about the pack before we even get into charging. So we talked about the series and parallel configuration. We talked about the general layout. The module design is similar to Air, right? In the way that they're in those casings.
Yeah. So we keep the module design, and remember, the module design was actually put together in order for us to really enhance the space concept. The space concept from Lucid Air is carried to Lucid Gravity. These size of modules, the kind of brick size of modules, allow us the flexibility to really construct a pack with a right shape, right voltage, and also a much more enhanced cooling, actually, from that perspective. So the pack design may, from module point of view, seem the same, but we actually enhanced several things. It's a new cooling plate. It's a new actually improvement in safety of the module. We added potting to the module with a very effective way, because these are very high energy density still, and very power density cells, and we enhanced that. We also did a new cooling manifold connecting all the modules together. We have a new steel covers, lighter weights, materials. So it may sound similar architecture in a sense, but actually so many improvements and lots of added deductions for TR, thermal runaways, and things of that sort to improve robustness of all and performance of the pack.
So that is all music to my ears, because in general we have always been super impressed with the Lucid Air's range. We've been impressed with the peak power of that car, and no question, like that was for a long time that was the king. And now it sounds like Gravity is going to, kind of come above this. But I'm really curious about this thermal concept, because something we've run into with Air is hot spotting or certain areas of the pack getting warm. So with this new manifold with the plate, do you think we'll have a more even temperature across the
Yeah,
model?
so to be fair to the Lucid Air pack, uh, it has a very uniform temperature. However, our limitation in the Lucid Air was, to a large extent, is our air intake system and our radiator layouts. It's still, as I said, if you look at the C rate of Lucid Air compared to some new vehicles, like look at just C rate, it's still one of the top. However, I mean, the Gravity takes it to the next level. So we didn't just redesign or reinvent the cooling system in the pack, but in the entire vehicle. So our radiator layout is different in Gravity, completely different. Our chiller size, our compressor size, significantly larger by 20 to 30% in terms of capacity. And our cooling pumps and all that. Right now, Kyle, we do have of course, we did have a small team back then. Right now, we have an amazing team that can systematically understand all the bottlenecks. And I have excited group of people who really work together across the board to optimize overall systems everywhere. Where are the gaps? Where are the bottlenecks? And we remove it, and we had to really bring them all together up. So it's
Okay.
not just the pack, but the pack in Gravity cooling also changed and improved at the pack level. But
So
yeah. Mhm.
I mean that's great. That's what we wanted to hear. That it's not just like take a Lucid Air pack, put it into Gravity. There's like real changes here from a structural, from a cooling, from a cell. I mean, it's all going to be optimized for this thing. So now we can actually get to what this whole video is about, which is charging. And we've already touched on it a little bit. So we spoke briefly about the maximum voltage of the pack, 926 volts at 100%. It's 800 something nominal, right?
802 volt roughly, I think. Yeah.
Okay, so that's pretty great. It's NMC or NCA?
It's NMC.
NMC, cool. And why this chemistry? Why not go with some of these? Like we've seen some crazy. I mean, this is kind of going back into the cell thing, back on the decision. But NMC, in your eyes, is this the best way to get the cost, power, and energy density performance?
Are you referring to compare it to NCA or some other
Yeah, to
chemistry?
LFP, because we're starting to see like the Chinese
Yeah.
go LFP.
Yeah. So I think, of course, LFP is very uh, uh, exciting and proven cell that can charge fast, can give you enough range in most applications. However, I mean, if we have the choice to do higher energy and high power, I think we will still pick NMC. And for a platform like Gravity, I think NMC is the right chemistry. And I know I said you will experience the charging capability of Gravity sometime soon. And you will know that range is still important for many people. I myself find myself also when I drive a vehicle with 200 miles, 250 miles, I have a vehicle from that. And I do a few trips around the town, and I find myself I need to charge every now and then. Trust me. And but so NMC with you know the charging speed or performance is actually not because of LFP. I mean, or NMC. It's really because of the design of the cell, from the grain size to the thickness of the loading, the layer of the active material, to the tapping, which means how to reduce resistance, to the cooling. So LFP typically is known to be fast charging because it goes with a blade or by other or pouch or some other types of cells that lend themselves to be cooled more effectively because they have to multi-tap technically, naturally. The NMC cylindrical cells don't have that type, but they can have, or typically don't. Some do. Let me just correct that. Yeah, so NMC is fantastic chemistry for this application.
Totally agree. So when we spoke with Peter before on the charging, we talked about 400 kilowatt peak, pretty juicy curve. I mean, at 50% state of charge, can you talk about kind of what that crossover? I think that's something we look at a lot. Obviously, what matters to the consumer is how many miles of added range are you putting into the vehicle for the time you're there. But just for that SOC over power curve, which is really just for the nerds, what do you think that 50% number is going to be?
So I know we're going to talk charging curve, and I hope also we'll touch on the efficiency too, because they are combined. As I've seen some comparisons recently in your channel, where efficient vehicle compared to a more high charging vehicle, and maybe they drive the same or similar. So what if we can do both? That's the question, really. I mean, we kind of meant it when we said compromise nothing. Charging was on our really radar. About gravity. I hope really you will kind of admit and say, yes, this is it. But to answer your question, 50%, I mean, of course, there are always some trade-offs in engineering. I would be lying if there's no trade-offs, then we can get you 1,000 miles, 600 kilowatts of, but you take it in a relative term, right? And from that point of view, at 50%, you will surely be charging over 200 kilowatt when you access the high charging powers. But the C rates, which is not just the power, right? C rates would be very close to 2C. And for people who don't know, the C rates is your charging current compared to your battery size and also the amp hour per cell. Basically, you divide your current with a number of parallel P with 130, and also you divide it by the amp hour, which is, let's say, 5 in this case. For this cylindrical 2170 cell.
So love it. I mean, that's music to my ears. Sounds cool, but you're totally right. This is going to be, if not one of the most, maybe the most, I think the most efficient SUV on the market, especially considering its size. And so, the 10% challenge is literally built to showcase what this thing can do.
Exactly. I love that test, honestly, and it's very, very great case, very great demonstration to understand road trip capability of those EVs. I mean, it's indeed a good test. Yeah, so we look forward to that test. Yeah.
Okay, so supercharging, the last topic, rear motor boosting power. So we've seen, just to lay it out for our audience, there's multiple different ways that you can get high voltage cars to integrate with, I will say, legacy charging equipment that is sort of old school, outdated, and not supporting the future of EVs, which I believe is high voltage. And Tesla has the most ubiquitous, most reliable, best stations. It's like all great until you get up to two problems. The first is cable length on the existing V3 posts. And the second is they don't support high voltage because they've never needed to. So, for example, there's certain vehicles like Cybertruck, that's a high voltage vehicle that splits the battery in half. Macan and Q6 e-tron do it with PPE. Hummer does it, but in the other way for high voltage charging. So split pack is an option. It's been well explored, it's been well done, and there are trade-offs. There's also the other two ways of doing it. The first is like what Lucid Air does with the Wonder Box, and sort of Taycan with their split pack in a box. And then there's also the Hyundai Kia Genesis rear motor boosting situation. So, why did you choose what you chose for Gravity, and how did that all come to be? Because I remember we spoke about this like 2 years ago or a year and a half ago, and you're
Yes.
like, "What should we do?" And I'm like, "I don't know. I would just split the pack because it's the easiest and simplest and cheapest solution with the
It,
trade-off."
it
That,
sounds it sounds on paper the cheapest. No, sorry, go ahead.
yeah,
Yeah.
yeah. No, go ahead,
Yeah.
please. I'd love to hear your thoughts.
Yeah, so Kyle, of course, yes, I remember very well asking you, as I know. I think, yeah, I would say I'm not complimenting you. I think you are probably number one in charging knowledge, breadth of what other EVs know. I know you have your own like unique use cases, and sometimes just for fun. I know that, and we talked about those. But the charging is still very important for us, and accessing the Tesla Supercharging network is great for the experience. We know convenience, reliability, peace of mind are key for the adoption. That reflects also in Tesla's success as a company. The superchargers network is really key for that. And for the Lucid Air, as you said, back then we designed it to allow charging with the 400, 500 volt charging network. Back then it was the EVgo's and the charge points and so on, and some in Europe. And it was the right decision for us because you don't want to over design the system. Never thought one day Tesla would open it. We talked about it, but we ruled it out as an option or possibility just to be. And it could be, you can argue, just inside or short side, or but we chose the 1,000 volt system. And I think overall, if you want to pick one back then, I would still, even we knew if Tesla would open it, we would pick the 1,000 volt for the Lucid Air. It's a future proof. It's really pushed the industry forward. I think we have to, we push Electrify America and other charging networks to really fix their network at high voltage. And the Lucid Air was the one really, we were working very closely with Electrify America, and the Signet Surge and all that stuff that we fixed with them. Actually, we pinpointed the problems to them and tell them how to fix it sometimes, to be, and it's in a collaborative manner, for Gravity, of course, when things open to us in that manner, we have to take it seriously as a business, what to do, how we go forward now with our charging strategies. And we considered split pack. We considered upgrading the Wonder Box to higher power. We considered buying another box. And we considered boosting through our drive unit. And I was with a few colleagues in Santa Cruz Beach. We had offsite, and we playing volleyball. And we thought, what if we use, just a step back. The boost charging through drive unit was patented, thought about long ago. And my name is on that patent. But to do it in a Gravity was very difficult and challenging in many ways, because our charging port was already designed in the front side. So to do a front boost would be a little bit lower power, because our high power motor is in the rear. And it would be step forward even with lower power motor. It could be 130, 150 kilowatt. But us, I remember discussing with you, we said it should start with number 200. So, and we said, hey, if we use our rear drive unit, which is always what we call it here, it's a 4Y, it's a 4 parallel branches, very high power dense, amazing continuous power. And it's only Lucid can do that, honestly, with this power. And we said, if we change the charge port to the rear, it would be more compatible with V3, and it would be closer to the drive unit, and then it's the magical solution, and it's lower cost. It's much lower cost than buying a separate box or even upgrading the MPP, which is. So we looked at the packaging, we looked at the architecture, and we knew how to do it, like technically on paper, of course. But then when you execute it, you face lots of challenges. And this is a project usually would take 2 or 3 years in any other company, Kyle. And I actually, your visit is about 1 year ago, Kyle. We did it within roughly 1 year.
And that is
It-
also a change.
We didn't even have concept before that. From concept to production, and it's in production today.
So yeah, I mean, what's really interesting is this has left the Gravity with two different market-specific body in whites, because you'll have the Euro and Middle East spec with the front charging port, where they just use the Wonder Box, right?
Yeah. So of course, this decision was taken back then, and it can always be iterated and changed, because changing the EU version to rear with the CCS, that's probably very easy, because we all have the routing. We can do boost there if we decide to. From timing point of view, and we want to ship to KSA vehicles as soon as possible. From need point of view, because Tesla, although is open there's some limitation for plug and charge and all that, probably, we decided not to do it at this point. But yeah, I mean, one point, of course, that Peter mentioned and we mentioned relate to the boost also decision for split pack is two other reasons that I didn't mention, or I think Peter alluded to the voltage utilization from the charger, which is really part of also the decision not to do a split pack, because each vehicle has its own unique situation. I'm not saying split pack is inferior in every other vehicle. Generally, with boost, you can always utilize the highest voltage the charger is, which is really reduces losses on the cables. For example, you can get 200 kilowatt in Gravity with less than 500 amps. It's 4 or something. So that's quite an achievement in your cable heat. And when we have a drive unit that's thermally super capable and very efficient, it's for the charging is much faster. And the second choice or reason is that with the Lucid Gravity, as you know, we have touring trim and Grand Touring trims. They have a different battery sizes. And in order for us to do split pack, by split pack is not simple either, by the way. The number of contactors you add and the balancing and the BMS, it's actually, I can tell you we wouldn't be able to do it in 1 year. Trust me. But because we have 16 mod for touring and 22 mod packs, splitting the back here for 16 mod, the center point will always move around, will be complicated to implement. But maybe it's not your problem as a customer. The other problem is your voltage is lower. Of course, we would use the same module, and it becomes actually 100 kilowatt or 110 kilowatt, as you've seen some split packs coming up with 120, 130 kilowatt. So I don't think that's a good solution for us.
Yeah, when you have this sort of like, okay, so your top battery pack's always going to get up to 926 as the full system, but as soon as you start removing modules for the smaller ranges, you're dropping voltage by each module.
Yes.
And then you have to split that sort of medium
Yes.
voltage in
Yes.
half. And then you're like at 230 volts plus
Yes.
looking
Or
for 500 amps.
and at low SOC, yes. So and other companies did that, and they accepted that trade-off. We really didn't want to. And other cool thing, which is you're always charging even with a small pack at 225 kilowatt. Isn't it that cool? Because if you're touring, which is probably there will be higher sales, lower cost. So I think that's we don't want just. This is why I'm telling you earlier. It's not about just a 400 kilowatt. It's about the experience. We really meant it. Like we wanted to offer a charging capability that people love day to day.
So by the time this video goes up, in like 2 days afterwards, Lucid Gravities and Airs, or just Gravities, will have full access to the Supercharger network. Do you know how that rollout's going to happen?
So yes, of course, we're so grateful to Tesla working with us on this aggressive timeline. We're going to launch with Gravity in January 31st as we are ramping. Gravity, we're going to launch the Air afterwards, Q2 right now, tentatively. That's what we are targeting this year, of course. The other thing is we're going to offer adapters for both Gravity and Air. The Gravity adapters will be included and will be, I think the first, and my understanding to my knowledge, will be rated at 1000 volt 500 for the DC one. For the AC one will be 80 amps too, because we offer the 80 amp capability with all the bidirectional capability, including V2V, vehicle to home. That's not yet there, but stay tuned. All I can say for both Air and Gravity. And so the rollout will be very soon for Gravity customers.
So, I mean, all sounds pretty damn exciting. I can't wait. I mean, the next thing I need to do is just steal a car, and the problem is they have so much range. It's going to take forever to drain this thing just to do the charging test. So, okay, one last question, serious question. There's a lot of Lucid Air owners who follow our shows and our podcasts. There's also a lot of people who still will buy Air after Gravity is on the market, of course. How do you retrofit this fast charging to Air? Is it not worth it? Is it possible to get it to that car?
You know, when we made the decision, I was myself probably the most passionate about providing Gravity with the solutions, both high voltage and the lower voltage solutions. But I am also a realist, where we put our best resources and how we make the best decisions for our company in general. Now, that introduction sounds like we may not do it for Air. Of course, the Air is in production, and it takes you more thinking to change the platform, unless you combine it with other changes, other refresh. And as of now, there are no plans announced about the Air, let's say native NACS yet, but it's going to be inevitable. But are we going to be changing the capability of boost or not? That's to be honestly, Kyle. However, you know, V4 is coming. We want to kind of see how the rollout goes. Hopefully, Tesla shows strong ramp for that, and then it may be, and the industry already moving through, or most of them through native NACS and 1000 volt. But for Gravity is mandatory to kick off the brand excellently, impressively, because you know it really is so critical. Imagine we came with still a CCS and no boost. I think this is no go for me and for many others here, and we're super excited and thrilled really to offer this for our Gravity customers. But Lucid owners, they understand the decisions why we made, and we will address it in the right time.
Yeah, I think very reasonable. This is not like a simple change that you can just throw in. This requires, either running high voltage lines down the entire car on the Air, which is lossy and expensive, and maybe there's not even routing space, or a literal body and white change, which is really a difficult thing to do. So, regardless, on the Gravity topic, this is what we wanted to hear. This was the question mark when we reviewed it for the first time. We're like, drives amazing. I was lucky enough to drive it, and it's by far the best driving electric SUV, maybe actually just electric car in general, looking back on the market. It just does everything. It's got all the space. I think it looks really cool. It's got seemingly great software. I played around with one recently, and it was
more to come, a lot more to come in that area.
So it's like, Lucid Air, you and I know, I had a lot of small little complaints about that car that have been fixed with Gravity, almost all of them. And so it's like, we just needed to know the charging was going to be good. And now we know the charging is going to be good. And so it's like, damn, that's everything we wanted.
Yeah. Well, thank you, of course, for all the support through this journey with Lucid in general, Kyle, and out of Spec in general. I know you share very fair and critical feedback to all of us to improve. As you said, I think Gravity really defines SUVs in many ways, right? It's really reimagined in terms of its space, concept, its profile, its sportiness, performance, shape, and now the charging and the user experience for software. Stay tuned soon. There will be lots of improvement from the one that you saw also recently. We are committed to really make it compromise nothing vehicle.
Love to hear it, and can't thank you enough for joining on the show as well. It was great to have you and Peter join us for this. We got to have you guys on more often. I feel like we should just go on and do like a weekly chat about cars in general. But of course, this would take too much time.
Well,
So
Nick maybe is listening here, and maybe we could do something. Stay tuned, and happy to chime in from time to time.
amazing. Well, thank you for joining on the show. Congrats on making the Gravity sound like a charging monster. Obviously, we can't wait to see it and prove it in the real world.
100%.
I cannot wait to get this thing on a 10% challenge on a nice day with the perfect charger and just show the world what it can do. And really, we should run the Escalade IQ next to it as well, just to show the two worlds.
Yes, we must really. I recommend it. I know the results.
Amazing. Well, thanks for joining again, and we'll see you hopefully on an episode soon, Emad. Thank you.
Thank you, Kyle. Thank you, Outspec. Cheers.
Isaiah, you're joining me to rapid fire hit me with all the specs. We just got the information ahead of the release. Super cool of Lucid to set this up for us so that we know how the Gravity charges. It's so important that it charges fast. Tell me the high level specs.
Yeah, so 400 kilowatt peak charging, but we'll hear in the interview it could be a little more. 926 volt battery pack maximum voltage. We're getting up to.
Think about that. Sorry about that. I want to dig into that. So Lucid Air was 924 volts maximum. Then Neo ET9 came out, and it's not in production yet, and they did 925 volts. And now Lucid Gravity is 926 volts, back at the top in the car industry. And again, so the viewers know, this is at 100% state of charge. Nominal voltage is just over 800 volts,
right?
At, where you would calculate that.
Perfect. Crazy numbers. Lucid is performing so well on that front. Up to 450 miles of range on staggered wheels, which I thought was pretty interesting to note. I mean, staggered wheels are known for better efficiency and performance and handling on some regards. So that's not like what we're seeing here for the Gravity. And then they claim 200 miles in less than 12 minutes at peak charging rates. And that's with their new Panasonic cell.
Yeah, so just to break all that down really quick, that 200 miles of charging rate is based off their EPA cycle, not our highway testing. And so, we actually achieve basically, at least with the Air, their EPA number in our 70 mile per hour highway test. We did 510.5 miles at 70, and they rate 512 on that car. So it's like basically identical. We'll see how Gravity lines up. So that sounds really great for like a 10% challenge king here, which will be really cool. But we run that at 80 miles an hour, not 70. Just keep that in mind. The second thing is the staggered wheels aren't just staggered from a width perspective, which is how most cars are. They're staggered from a wheel sizing perspective. And that was actually, we spoke to all the chassis engineers about that. It had nothing really to do with range. It was just a design choice, which I thought was interesting. And so they are, I believe, staggered width as well. And that does make a difference for, bouncing range and handling characteristics. All of that, those compromises, even though Lucid's compromised nothing, but everything is a compromise. All of those compromises were put into our initial review of the Gravity. Before we get into the interview, Isaiah, what's your impression of the Gravity's charging? We already know we love it. We already know it's impressive. We already know it drives great. What do you think of the charging?
Before the interview, I was impressed. I know it's Lucid and this is their next generation vehicle. I thought it was going to do well, but after the interview, I think I have a whole different perspective on the Gravity and what it will do charging performance wise. I want to see this thing on the road. I am so excited to see the 10% challenge test on the out of spec reviews motoring channels, I'm looking forward to seeing this thing on the road because, I mean, it seems to be up there with the likes of the Porsche Taycan.
Yeah, it's hard to say exactly how close it'll get, but it definitely sounds like a monster. In the
Yeah.
SUV category, it sounds like they're ticking all the boxes. It's not worth delaying anymore. Let's get into the main purpose of this video, which is the interview with Emad and Peter, mostly Emad. And I think you guys will enjoy it. I certainly did and appreciated. Ask you a couple questions.
Okay.
Well, guys, again, a huge thank you to the Lucid team for letting us share this news right at the embargo lift. Always great to get to chat and nerd out with some of the coolest engineers on the planet, both Peter and Emad. They make a great team. I really think we should do like a podcast series with those guys, like whenever we can. Don't you think, Isaiah?
I would love that. I mean, Ahmad had some amazing perspective there. Everyone at Lucid seems to be a genius at what they do and great at explaining things for someone who's just kind of into more of the surface level things. And so it's really easy to understand. I would love to have him on here more often.
Yeah, I think also the point of this podcast is maybe in the future we're going to get more engineers on, more people in the industry that are like, that are legit, because there's a lot of people that can like read a press release and have zero substance behind it. That's not these guys. That's not anyone I've met at Lucid. Everyone at Lucid is like an enthusiast. They know their shit. They're super dialed in. And I really appreciate the feedback or them taking our feedback and helping make Gravity even better, based off of us pushing them, or in the early days being like, no, it's really gotta start with a 200 kilowatt number on superchargers as an example. And it was just great to have the interview with those guys. So here's hoping to more. Sounds like the Gravity is going to be a monster. Isaiah, I'll leave it with your final thoughts.
Yeah, I want to ask you, Kyle, what are you anticipating for some content that we'll see on the out of spec channels?
I don't know when we can drive Gravity. I don't think it's going to be long. They're in production. They have access to charging in like a few days. They're in customer hands. So I just need to find like whatever customer will let us borrow theirs first, basically. Or maybe Lucid can hook us up with one. Um, because I think we need to. The problem is it's winter time. And like 10% challenges, like some cars do really well in the winter time, but cars that are very like efficiency heavy need like optimal conditions. And I always try and get optimal conditions for the benchmark cars. Like some cars like a Chevy Equinox or a Blazer, like if we're off by a couple miles because it's cold one day, okay, we're in the region. With the benchmark cars though, it's so like every test we do the same way. It's just on which weather condition can we get the car in, because we do run real world. And so that's going to be the challenge, because that car's launching in the middle of winter and we're in Colorado. So we might actually go to like Arizona. We might go somewhere else to do the testing. It just, for a 10% challenge, we need a 400 kilowatt charger. And
That
there's none
too.
here in Colorado. But I just spec'd our Alpitronic HYC 400, sent them what we want on it. So, but that's going to take a minute to get installed. So it's probably not going to be ready in time. Yeah, I don't know, Isaiah. I don't know how we're going to do the 10% challenge on this. We're going to have to find a Mercedes charging hub or an Iona
Right.
station that uses Alpis and find it next to a flat stretch of highway somewhere that's not cold.
BP Pulse has a few HYC 400s opening on the West Coast pretty soon. So maybe you'll be able to find one of those. Otherwise, with the amount of range this thing has, you might have to drive over to the East Coast and do a little road trip in the Gravity.
Yeah, exactly. I think that, the Southeast could work. We'll have to look at the areas at where we can actually get the highest charging power, which is cool. But I think with something like this, it's worth running 10% challenges. We'll do it one on the Supercharger network, because if you have a Gravity, that's going to be your preferred charging spot, unless you're in a super hurry where you need the crazy performance. But Superchargers just rock. And so they have the best locations. Like a lot of people are going to go there. Maybe you hit an Iona station, which would be amazing, but they're just launching now. So like the grand opening hasn't even happened, the public launch of their network. And the Mercedes hub's awesome. So you have optionality with this car, but I think for the 10% challenge, we have to run both. The range test, I really want to run in Colorado because we have elevation conditions to consider on that one. And we can also run it in the hogback and some other stuff. So we may just need to wait for unseasonably warm day and just hope we have a Gravity here or wait until spring, which isn't that far away. And other content to come, well, just the normal stuff. Rustic ring towing test. This thing can tow a bunch. Of course, all the charging analysis. We didn't really discuss curve so much in this video. It's more just the theories behind the cell, the pack architecture, the motor boosting situation, which I love. And regardless, with any new benchmark vehicle that launches in our market, we have to do everything with it. So it's going to be an intensive testing program that we throw at this thing as soon as we're able to.
I'm excited.
Me too.
Awesome.
Yeah, can't wait. So anyway, I think that's the show. I'll let you say goodbye to the viewers however you like to do it, Isaiah.
Yeah, well, thank you guys so much for watching. Let us know everything that you guys learned, what content you want to see. Any questions you guys have, leave those down in the comments below. And yeah, we will see you guys in the next episode of the Out of Spec podcast.